doing from the thermal physics questions from page 18 onwards. We have a 240 volt, a 60 watt lamp, and it is connected to a 240 volt supply. So the lamp is having a power of 60 watts and it is connected to a supply which is 240. So it receives the same voltage. Lamp is having a constant temperature. The rate at which the lamp transfer energy to the surrounding. Rate of energy transfer is also called power. So rate of energy transfer, so that will also be 60 because like power is refers to a rate of energy transfer. So if the rate of energy transfer as they ask, so that will be same as a 60. The names of the thermal processes which a lamp transfer energy to the surrounding. Like when you light up this lamp, how the energy is transferred to the surrounding. Processes, so you have to mention two of them. The first one, okay, convection and radiation both. Even conduction is acceptable. Why conduction is acceptable? Because what will happen when what will happen because of its heat energy from the lamp, when it will come in contact with the air, first the conduction happen because that's how the energy first transferred to the air, and then from air the convection happen. Hot air will rise up and the cold air will move down. So even conduction is also acceptable here. Radiation and convection are more appropriate. Figure 4.1 shows a thick copper block that has 400 degrees centigrade on one side is a dull black and the other side is a polished and shiny. In experiment 1, the thermometer bulbs are both painted black. They are placed at equal distance from the surfaces of the block. The maximum temperature shown by each thermometer recorded. Explain any difference between the maximum temperature shown by the two thermometers. We have two thermometers. One is facing a dull black surface, another one is shiny polished surface. Which thermometer will show a greater change in temperature, maximum temperature? That's right, dull black. And so one mark for mentioning dull black. And the other points you have to refer, like thermometer A. Actually, thermometer A is one mark. And then dull black is a second mark. And why dull black? Because it is a good emitter. Good radiator or emitter, you can also say, of heat energy. Dull and dark surfaces are good absorber and they're good emitter. Absorber, but if the reason why I did not use the term absorber, because they already mentioned it is heated to 400. So already the metal is hot and the surrounding temperature is like 25 degrees. So heat always heat energy transfer from hot object to cold object. So in this case, because it is already hot, that's why we are not supposed to mention absorber. We have to use the term emitter. Good absorbers are good emitter, but why we have to use the term emitter rather than absorber? Because it is already hot, so it will release energy to the surrounding. In experiment 2, the thermometer bulbs are both shiny colored. They are placed at the same distance from the surfaces as in experiment 1. State and explain any difference in observed maximum temperature. So observed maximum temperature change, temperature change will be less because the shiny surfaces are good reflector. So smaller change in temperature. And reason is that because the shiny surfaces are good reflector. Figure 4.2 shows a firefighter wearing a shiny silver colored clothing. State the benefit of a firefighter wearing a shiny colored clothings. So shiny surfaces are poor absorber or good reflector. So the body temperature or his body will not absorb like too much energy, as most of the energy is reflected to the surrounding. Figure 5.1 shows some gas trapped in a matching cylinder with a piston. The position of the piston is fixed. So it means it is not changing. It has a constant volume. The cylinder is moved from a cold room to a warm. In terms of the molecule, what happened to the pressure? But you have to refer in terms of the molecule. First, what will happen? Yeah, it will increase the energy or the kinetic energy or the speed. So when it will absorb energy, the kinetic energy will increase greater speed because the particle move faster. They will have a greater momentum. That's good. And when they have a greater momentum, they will have a greater change in the momentum. And they will collide more frequently. That's correct. So they will collide more frequently. Hence, the rate of a collision will increase. So exert greater force on unit area, create a high pressure. And it increases the pressure. In part B, the piston is now released. It moves to the right and finally stop. Explain these observations in terms of the pressure and the volume. So first, the piston was fixed. Then as they mentioned, is moved towards right and finally stop. So first, you have to explain this observation. So what will happen when it start to expand? The volume will increase and the pressure. Like initially, why the piston will move out? Because the outside pressure is less and inside pressure is more. The pressure from inside is greater than pressure from outside. That's why it move outward. Then what will happen as the gas expands, the volume increase, so the pressure will decrease. So again, what will happen? The outside pressure balance with the inside pressure. That's why it will finally stop. So the points you will mention, initially the pressure will be high. That's why it is being pushed out, move towards right. So first, initially the inside pressure is more than the outside pressure or the atmospheric pressure. But when the gas expands, the volume increase, so the pressure decreases. So the outside and inside pressure balance out each other. So when the outside pressure equals to inside pressure, it will stop expanding. So these are the questions from thermal physics.